Hello, welcome to 2.3, the product and quotient rules and higher order derivatives. Product rule. The product rule, product of two differentiable functions f and g is itself differentiable. Moreover, the derivative with respect to x of a product is, ready for this, f of x times g prime of x plus g of x times f prime of x. So it's the first function times the derivative of the second function plus the second function times the derivative of the first function. So example 1, we are to find the derivative of h of x equals 6x plus 5 times x cubed minus 2. So h prime of x is going to be this 6x plus 5 times the derivative of the second one. That's going to be 3x squared plus this second function x cubed minus 2 times the derivative of the first one, which is just 6x. So our h prime of x is going to be 18x cubed plus 15x squared plus 6x to the fourth power minus 12x. Oh, I'm sorry, that just should be a 6, not 6x. Minus 12. That's cubed. Okay, so it's h prime of x is going to be 18x cubed plus 6x cubed is 24x cubed plus 15x squared minus 12. Let's look at the next one. Find the derivative of y equals x cosine x. So here's your f. Here's your g. So y prime is going to be x times the derivative of cosine is going to be negative sine of x plus cosine of x times the derivative of x is just going to be 1. So y prime is going to be negative x sine x plus cosine x. And then let's look at this next one. Y equals the square root of x square root of x times sine of x. So if our f of x is the square root of x, our f prime of x, that's x to the 1/2, is going to be 1/2 x to the negative 1/2, which is 1 over 2 x to the 1/2, which is 1 over 2 times the square root of x. And our g of x is the sine x. So g prime of x is going to be cosine of x. So y prime is going to be our f, which is the square root of x, times g prime, which is cosine of x, plus our g, which is sine of x, times f prime, which is 1 over 2 times the square root of x. So y prime is going to be equal to the square root of x times cosine of x plus, I'll put this first, 1 over 2 times the square root of x times sine of x. And that is the product rule. Okay, I'm going to go on to the quotient rule next. Think quotient, think of division when you're dividing two functions. The derivative with respect to x of f of x over g of x. Now get this one. G of x, our denominator, times f prime of x, the numerator, minus now f of x, the numerator, times g prime of x, the denominator, over the denominator squared. This is not the derivative, this denominator squared, as long as the denominator is not 0. So a way to remember this rule is that if you consider the numerator to be high and the denominator is low, you could say the derivative of high over low is low d high, d meaning derivative of, low d high minus high d low all over the square of what's below. Or low times the derivative of high minus high times the derivative of low over the square of what's below. So in words, I said the first one, no, I said the second one. First thing would be low d high minus high d low, square the bottom, and off we go. That's kind of a saying people have come up with. We're going to go on to the next page now. Now we're going to use the quotient rule to differentiate. So g prime of t is going to be low, which is 2t minus 7 d high. And what's the derivative of what's up here? That's just a 2t. Minus high, which is t squared plus 2, times the derivative of what's below, that's 2, all over the square of what's below, 2t minus 7 squared. So that's 4t squared minus 14t. Then we have minus t squared times 2 is minus 2t squared. Minus 2 times 2 is plus 4 over 2t minus 7 squared. And we can clean this up a little bit. 4t squared minus 2t squared is 2t squared minus 14t plus 4 over 2t minus 7 squared. And you can expand this if you want. Next one, rewrite and differentiate without the quotient rule. We have y equals 5x squared minus 3 over 4. So you could write this as y equals 1/4 of 5x squared minus 3. So that y prime would be 1/4 times, well, the derivative of 5x squared, that's going to be 5 times 2x, and that's it there, minus 0. So it's 1/4 times 10x. That would be 10x over 4, which is 5/2 x. Okay, go on to example 6. I'm going to scroll this up. Okay, use the constant multiple. So we have the original function x squared plus 4x over 6. We can rewrite this as 1/6 times x squared plus 4x. Differentiate becomes 1/6 times 2x plus 4. The derivative of x squared is 2x. Derivative of 4x is 4. That becomes, well, 2x plus 4 over 6, or x plus 2 over 3. Next one, we have y equals 4x cubed over 5. We can write this as 4/5 x cubed. So that y prime would become 4/5 times 3x squared, which is going to be 12x squared over 5. Now the next one, I treat this as 5/4 times 2x minus 3x squared all over x. So you can divide that out. That's 5/4 times 2 minus 3x. So our derivative is going to be y prime is 5/4 times what? The derivative of 2 is 0. Derivative of negative 3x is just 3, minus 3 there. We end up with negative 15 over 4. And this last one, you could treat this as 5/4 times 1 over x squared, which is 5/4 times x to the negative 2. So that y prime would be 5/4 times negative 2x to the negative 3 power. And to simplify that, y prime would be, this reduces, negative 5 over 2, because of the negative, x to the negative 3 or negative 5 over 2x cubed. I'll take both these answers. Let's go on to the next page. The derivatives of trigonometric functions. We already saw sine and cosine, but here we see it for tangent, cotangent, secant, and cosecant. So the derivative of with respect to x of tangent of x is secant squared x. The derivative with respect to x of secant x is secant x tangent x. So I don't know if you're expecting something different. Derivative with respect to x of cotangent x is negative cosecant x, cosecant squared x, and the derivative with respect to x of cosecant x is negative cosecant x, cotangent x. So example 7 says, find the derivative of the trigonometric functions. F of x equals sine of x over x. We're going to use the quotient rule here. So looking at low, which is x, d high. Derivative of sine is going to be cosine of x minus high, which is sine of x, d low, derivative of x is 1, all over x squared. This is x cosine of x minus sine of x, all over x squared. And the same thing for the next one. Y prime. It's going to be low, which is x, d high. Derivative of secant is going to be secant x tangent x minus the high, which is secant x, times d low, which is 1. Derivative of x is 1, all over the square of what's below. That's going to be x secant x tangent x minus secant x, all over x squared. Okay, the next concept is higher order derivatives. We talked about velocity being the derivative of the position function. What's the derivative of velocity? Talked about the change of velocity with respect to time. That's acceleration. How is your velocity changing with respect to time? Is it constant? Is it zero change? Is it going up by a regular amount? What's going on? That's acceleration. Acceleration is the derivative of the velocity function. It's the second derivative of the position function. So take the first derivative and take it again. That's the second derivative. So higher order derivatives, the second or higher derivative. First derivative, we've seen this, has the one little tick mark. Second derivative, 2 tick marks, and in this notation, you've got to be real careful how this is written. This 2 goes like a superscript for the d in the numerator, but it's after the variable in question in the denominator. So second derivative of y with respect to x. Third derivative, 3 tick marks, and you guessed it, 3 there and a 3 there. The third derivative of y with respect to x. Fourth derivative, you have a 4 there in parentheses. Now we don't do 4 tick marks now. Now we put in parentheses. And when you see something in parentheses like that, it means a fourth derivative or fifth derivative. It doesn't mean raise to the 4th power. Fourth derivative of y with respect to x. Nth derivative, this should have been an n, not a 5. And here, nth derivative of f with respect to x. This would be the nth derivative of y with respect to x. Okay, let's go on to example 8. Find the second derivative. So our first derivative is going to be 4 times 3 halves x to the 3 halves minus 1, which is going to be 6x to the 1/2. 3 halves minus 1 is 1/2. Our second derivative is going to be 6 times 1/2 x to the 1/2 minus 1. That's 3x to the negative 1/2, which is 3 over the square root of x. We'll go on to our last problem from this section. We're going to find the second derivative of this. F of x equals x squared plus 2x minus 1 all over x. So our first derivative is going to be low d high, so x times this derivative up here. Derivative of x squared is 2x. Derivative of 2x is just 2. Derivative of 1 is 0. Minus high, which is x squared plus 2x minus 1, d low, which is 1. The derivative of x is just 1, all over x squared. So our first derivative, let's just clean it up a little bit. This is 2x squared plus 2x minus x squared minus 2x or plus 1, all over x squared. My orange marker here, there it is. So we have plus 2x and a minus 2x. So 2x squared minus x squared is going to be x squared plus 1 over x squared. So let's look at our second derivative. It's going to be low, which is x squared, d high. The derivative of x squared plus 1 is 2x. Minus what's up top, x squared plus 1, d low, that's 2x. The derivative of x squared is 2x. All over the square of what's below. What was below? X squared. So this is going to be 2x cubed. And minus x squared times x is minus 2x cubed. Minus 1 times 2x is minus 2x. Over x to the 4th power. So our second derivative of x is going to be, well, these 2x cubes are going to subtract out. We have negative 2x over x to the 4th, which is negative 2 over x cubed. And this would be our second derivative of what we started with. Looks a lot different, doesn't it? Okay, that'll do it for 2.3. Send me your questions and I'll see you guys online. Thank you.